So students, we will continue with the chemical properties of ammonia. So the first one you can see is that the reaction which I have given it on the screen, that is oxidation of ammonia, simple oxidation. That is, when ammonia is being heated with oxygen, what you get it is that you get nitrogen and water is being formed. Now how can we do this particular experiment? Now I will show you the experiment here. What we will do is that, see, here we are taking two glass tubes. Through one glass tube we pass the ammonia gas and through other we pass the oxygen gas. Now here of course a cotton will be there, a cotton wool will be there, and when you will, that is, burn the ammonia gas in presence of oxygen, because oxygen gas is being passed through here. When you will burn the ammonia gas in presence of oxygen, you will see it burns with a, that is, greenish yellow color. Can you see it there on the screen? That the picture you can see it there, it burns with a green or a greenish yellow flame. Why? Because nitrogen and water is being produced. Don't think that here chlorine is being produced. No question of chlorine. Where from chlorine will come? So when ammonia is burnt in oxygen, alright, here the glass wool means the glass wool, it is not being shown in the figure, but actually we are taking the glass wool there because so that the gas will diffuse easily. Alright, below, above the glass tube B, you can keep a glass wool there, so that the gas will diffuse easily. For that particular purpose, nothing else is there. So when ammonia is burnt in oxygen, simple oxidation, it gives you nitrogen and water. It burns with a greenish yellow color flame. Alright, now next is when ammonia is burnt in presence of catalyst, that is your platinum. That is, it forms nitric oxide and water, and a large amount of heat is being liberated. It's an exothermic reaction. You can see the reaction there. 4NH3 plus 5O2 in presence of PT and 800 degrees centigrade give 4NO plus 6H2O, and heat is liberated. Now nitric oxide is an unstable gas. It combines with oxygen to give nitrogen dioxide, which is a reddish brown colored gas. You can see that, reddish brown colored. Now here also I will show you a figure. You can see here, see, I have taken ammonia, dry oxygen, and we am passing it through a platinum gauze. You can see in the figure I am burning it. Got it? Then what you find is that this gas is being passed, the nitric oxide gas which is being formed is being passed through that is what is that, a round bottom flask. We are passing it, clear? And the round bottom flask, what is there? Oxygen is there. This oxygen combines with nitric oxide, the colorless nitric oxide, to give you reddish brown colored nitrogen dioxide, which is being given out from this particular, what you can say, delivery tube. You can see that. So in this way, when catalytic oxidation of ammonia takes place, nitric oxide is formed, which combines with oxygen to give nitrogen dioxide, reddish brown colored fumes. Now remember it, when I will teach you the Ostwald process, this reaction is the first reaction of the Ostwald process. You will be finding it out. This reaction is the starting reaction of the Ostwald process. What is the Ostwald process? Ostwald process is being used for the production of nitric acid, for the manufacture of nitric acid. So you have understood the reaction here. That is, when nitrogen undergoes simple oxidation, ammonia undergoes simple oxidation, it gives you nitrogen, but when it undergoes catalytic oxidation, it gives you, that is, nitric oxide, which further combines to give nitrogen dioxide. Okay, now next is, that is, when ammonia that is reacts with HCl, it gives ammonium chloride, that is, acid and base reacts to give salt. Similarly, when ammonia reacts with nitric acid, it gives ammonium nitrate, another salt, acid plus base. Same thing with H2SO4, it gives ammonium sulfate. But when ammonium hydroxide reacts with HCl, it gives you salt and water. Alright, it gives you salt and water, ammonium hydroxide it gives you. Now here you must remember a few things, that perfectly dry ammonia gas, simple dry ammonia gas, no moisture is there in it, or liquid ammonia, it is neutral to dry litmus. Remember that. I said you that ammonia turns red litmus blue, but remember it, it should be moist ammonia, because in presence of moisture OH minus ions is produced. When ammonia reacts with water, it gives ammonium hydroxide, which dissociates to give NH4OH, NH4 plus OH minus. So in presence of moisture, listen carefully, in presence of moisture OH minus is produced. In absence of moisture, OH minus is not there, and hence it does not turn red litmus blue. So perfectly dry ammonia gas or liquid ammonia does not turn red litmus blue. Alright, remember it, this one. Now next is, what is liquor ammonia? Already I said you, once again let me remind you. An aqueous solution of ammonia in water is called liquor ammonia or liquor ammonia fortis. That is ammonium hydroxide. We can say that. An aqueous solution of ammonia in water. How do we pass it? Same thing, by the help of funnel arrangement, which you have seen in HCl. Because in HCl you have seen it. Why do we use funnel arrangement? Because HCl is highly soluble in water. The rate of dissolution of HCl is much more than the rate of production of HCl. We can say that. Due to which we use the funnel arrangement to prevent back suction. So here also same thing. To prepare ammonium hydroxide, we need also funnel arrangement, because the rate of dissolution, the rate of solubility of ammonia in water is much more than the rate of production of ammonia, due to which the back suction will be carried out. To prevent the back suction, we require the funnel arrangement, and by using funnel arrangement we prepare ammonium hydroxide, that is liquor ammonia. Alright. Acha. Now next is remember it, one more point. Ammonia is a weak base. It is not a strong base. Why? Because ammonium hydroxide, when it dissociates, it does not dissociate completely. It dissociates feebly. Means if you take 100 molecules of ammonium hydroxide, hardly 10 or 12 molecules will dissociate. Remaining that is 90 or 88 molecules will remain undissociated, proving that ammonium hydroxide is a weak base. Alright, clear now this particular thing? So in this way, next you have seen it there, that when ammonium chloride undergoes thermal dissociation, ammonium chloride, you can see in the lab, a white solid, a white sublimable solid, ammonium chloride, it sublimes, it gives you NH3 and HCl. For that reason I said it is a white sublimable solid. Why? Because on heating you get both gaseous, NH3 and HCl, and this particular process, you can see the reaction which I have given you, it is called as thermal dissociation. It's a reversible reaction. Ammonium chloride on heating gives NH3 plus HCl. On cooling, again it gives you ammonium chloride. Alright now? Okay, understood this particular thing? Now, next is, you have read it in analytical chemistry that ammonium hydroxide is used as a different, what you can say, a reagent, as a different reagent in different salts. Got it? You have studied. Once more, let me just remind you. With ferrous sulfate or with ferrous salt will gives you dirty green precipitate, isn't it? Like ferrous sulfate plus NH4OH will give you ferrous hydroxide plus NH4 whole twice SO4, ammonium sulfate, which gives you a dirty green precipitate, but it is insoluble in excess of NH4OH. You have studied this. Similarly, you have studied ferric chloride. It gives you reddish brown PPT, which is insoluble in excess of NH4OH. Similarly, lead nitrate, when reacts with NH4OH, it gives you nothing but chalky white precipitate, which is insoluble in excess of NH4OH. All these things you studied. Zinc similarly will give you white gelatinous PPT with NH4OH, but it is soluble in excess of NH4OH. Alright, it is soluble in excess of NH4OH. Clear? Yes. Now, similarly, copper, it gives you a pale blue PPT with NH4OH, but it is soluble in excess of NH4OH, because zinc and copper forms respective tetraamine salt. Like zinc reacts with ammonium hydroxide, excess of ammonium hydroxide, that is zinc sulfate. It gives you ZnNH3 whole 4 SO4, tetraamine zinc sulfate. Similarly, copper sulfate, when reacts with excess of NH4OH, it gives you CuNH3 whole 4 SO4, tetraamine copper sulfate, which is an inky blue or deep blue solution. You have studied all these things in analytical chemistry. Just once again I reminded you this particular thing. Now next is, ammonia gas is also used as a reducing agent. It is used as a reducing agent. It reduces the metallic oxide to its respective metals. Like here you can see I have taken black color copper oxide. When I pass the ammonia gas through heated black color copper oxide, it gives you copper, brown color copper, you will be getting it. Similarly, if I take lead monoxide, which is yellow in color, and I pass the ammonia gas through it, I will be getting gray color lead. Now to show this particular experiment, I will show you another figure to you. You see that here you can see I am passing the dry ammonia gas through heated copper oxide, which is black in color. Can you see it on the figure? It's a black in color. It gives you, that is nothing but copper is being produced. Alright, copper is being produced, and that is the gas is the remaining gas. The gas is what? Nitrogen and water. It is being passed through, that is U-tube. First you can see the U-tube is being kept in a this cold water, rather I should say not cold water, it's ice cold water it should be, or a freezing mixture. where the water vapor condenses in that particular U tube to give you water. Can you see it there in the figure? That is, when you are passing dry ammonia through heated copper oxide, which is black in color, it reduces copper oxide to copper. So copper is being left behind there as a reddish brown color residue that remains behind, and the gases is being passed through. First it is being passed through the U tube. Now U tube is being kept in a ice cold water or a freezing mixture where water vapor that is condenses in the form of liquid water. You can see it condenses, and the remaining gas, that is nitrogen, is being collected by the downward displacement of water. You can see it there. So this experiment clearly proves that ammonia gas acts as a reducing agent. It reduces metallic oxide to the respective metals, we can say that. Or when lead monoxide, if you take it, you will be getting the same thing. Now I think you have got it, this particular thing. So next is ammonia. If it is taken in excess, then what it happens? And if chlorine is taken in excess, then what it happens? This reaction is very, very important. Very important, this reaction. So you can see, if I take excess ammonia and if I pass it through chlorine, then I will be getting ammonium chloride and nitrogen. That is dense white fumes, I will be getting it. That is NH4Cl. So 8NH3 plus 3Cl2 gives 6NH4Cl plus N2 when excess ammonia is passed through chlorine. But when excess chlorine is passed through ammonia, NH3 plus 3Cl2 will give you NCl3 and 3HCl. NCl3 is nothing but nitrogen trichloride, which is a yellow colored explosive liquid. Nitrogen trichloride, which is a yellow colored explosive liquid. So when excess ammonia is passed through chlorine, we get ammonium chloride dense white fumes. And when excess chlorine is passed through ammonia, it gives you yellow colored explosive liquid, that is NCl3. Are you getting the observation? This is the observation. In observation, you did not have to write everything. Just what you see, that you write. Like in the first experiment, in the first reaction, you can see an excess ammonia. So what I see there? I see only dense white fumes. You will say nitrogen. Nitrogen is visible to you. Nitrogen is a colorless, odorless, tasteless gas. So the one which is not visible, how will you write the observation? While writing the equation, you can write down. But observation, if it is asked, means you will say dense white film. Similarly here also, in the second equation, what you will say? You will say yellow colored liquid is being formed. Of course, it is explosive in nature. Got it? So in this way, so you always write the reactions. You write it down, and when observation is asked, you write only the observations. Clear now? Now next is, we'll come to the test for ammonia. So already we have seen it many tests. In the chapter while I was teaching you, you have seen it, the reactions. Like ammonia, first of all, it is having a pungent and irritating odor, by which you can recognize it. You will say, sir, many gases are pungent. Done. Okay, fine. Now it causes, the next one is, it causes irritation and burning sensation in the upper part of the nasal, what you can say, mucous membrane. I've said you that. Clear? And it brings tears to the eyes also in small quantities, and in large quantities, I said you, it is fatal. Okay, fine. Next, in indicators, you have seen it that red litmus is turns blue. I have said you, it's the only gas which turns red litmus blue, but it should be a moist gas. Mind it. It should not be a dry one. Methyl orange, it changes to yellow, and phenolphthalein, it changes to pink. Now next is the most important, what you can say is that if you bring a glass rod dipped in HCl near the mouth of ammonia, it gives you dense white fumes of ammonium chloride. This is one of the tests. Similarly, just now I said you that is an inky blue solution is being formed when you pass what you can say add ammonium hydroxide in excess to copper sulfate solution, then you get an deep blue colored solution, an inky blue colored solution, that is tetraamine copper sulfate. Alright, that is also a clear observation, and it is also a test for ammonia, we can say that. And the last and the most important one, the one which I have given you, the test of ammonia on the screen, you can see when it is passed through Nessler's reagent. When ammonia is passed through Nessler's reagent, now Nessler's reagent, remember it is a colorless solution. So when you pass through Nessler's reagent ammonia gas, it gives you a pale brown colored precipitate. A pale brown colored precipitate it gives you. Alright, so that is nothing but, you can see the reaction there. Nessler's reagent is potassium mercuric iodide. You can say that potassium mercury iodide K2HgI4. When it reacts with alkaline, I have said you alkaline solution, so hence I have to take KOH or NaOH, I have to take it, and ammonia gas. Are you following the reaction? Potassium mercuric iodide is your Nessler's reagent. Now Nessler's reagent you have to take in presence of alkaline medium. For that reason I have taken KOH. You can take NaOH also, no problem. So plus ammonia will give you an addition product. What is that? An iodide of Millen's base. The name of the product is. Now plus 7 Ki plus water is being formed, 2 molecules of water. The most important thing is that this particular reaction is used as the test of ammonia in the higher classes. When you go to class 11, you will do the detection of the cations and anions at that time. For the detection of cations, that is ammonium ions, you will see you will be doing this particular test. You will be doing this particular test with Nessler's reagent. This is the what you can say confirmatory test for for ammonia by using Nessler's reagent. Nessler's reagent, again I say you, it is nothing but alkaline solution of potassium mercuric iodide, which reacts with ammonia to give you iodide of Millen's base. We can say that. Now this is a test of ammonia. We can say that. Very important one. Now uses, you can go through it. So then I will tell you what are the uses. It is a source of urea. Ammonia is a source of urea. That is urea, you know the formula, NH2CO NH2. It is also a source of ammonium carbonate, which is used as a smelling salt. NH4 whole twice CO3, smelling salt. It is used as, basically it is being used for persons like those who are having, that is a fits disease, fits जिसको मिर्गी बोलते हैं, alright. So or those who faint, what you can say, regularly, basically, so they are being given, they are being allowed to smell this salt, alright. So that is ammonium carbonate, which is having a pungent smell of ammonia. By smelling the salt, they regain back their senses. We can say that. It is also used in baking and dyeing industry, that is ammonia. It is also used to prepare, what you can say, dyes and drugs. It is drugs means medicines, so to say. It is used in the preparation of baking soda, sodium bicarbonate. It is being used in the Solvay's process, you will read in class 11. It is used for the preparation of artificial silk. It is used in the preparation of alum, K2SO4 dot L2SO4 whole thrice dot 24H2O. We can say that. It is also used in the preparation of fertilizer, that is ammonium sulfate. It is being used. Alright, liquid ammonia, it is being used as a refrigerant in ice plants. Liquid ammonia is used as refrigerant. Why? It is highly volatile. Liquid ammonia is, it has got a high latent heat of evaporation because it withdraws large amount of heat from the body, and it easily liquefies under pressure at low temperatures. While teaching you Haber's process, I have said you that we are generally storing ammonia in the liquid state. Alright, it is easy to store ammonia in the liquid state because ammonia gas can be easily liquefied. So remember that what I said you, liquid ammonia is used as a refrigerant. It is used as a refrigerant. Alright, in ice plants. Why? Because again I repeat, it is highly volatile. It's gaseous, highly volatile. It has got a high latent heat of evaporation because when it evaporates, it takes away a large amount of heat from the body, from the surface, from where it evaporates, and it easily liquefies under pressure at low temperature. So hence, for that particular purpose, it is being used, got it, to as a refrigerant in ice plants. Got it? For that particular purpose, we can say that. And also the liquor ammonia, which is nothing but known as liquor ammonia 40s. Got it? It is being used to dissolve fats, grease, and so many other oils, which are the stains which are present in the clothes. Got it? For cleaning the clothes, which is having grease, which is having some oil stains and all those things, to clean that, we are using the liquor ammonia 40s or liquor ammonia, we can say that, a solution of ammonia, that is nothing but ammonium hydroxide, I said you. Alright, now next one more thing we will read in higher classes, that chlorofluorocarbons, you know that, CFC, which is said to be as chlorofluorocarbon, which is being present in your refrigerator, which is being present in your AC, are chemicals which, like liquefied ammonia gas, are used in refrigeration purposes, you know that. Alright, in AC and in your air condition and in your refrigerators, we are using CFC, chlorofluorocarbon. Alright, so which is also known as freon, which is said to be as CFCl3 and or freon, we can say that. It is being used just like liquefied ammonia as refrigeration purposes. Unlike liquid ammonia, chlorofluorocarbon enters the atmosphere due to their excessive use as coolant in the refrigerators and AC plants, or it is also being present in your sprays, body sprays, we can say that, and cleansing agent. It is being there. We are using that choline and all those things. It is being there. Alright, and this causes the depletion of the ozone layer. Alright, which one? CFC. It causes depletion of the ozone layer. And you know what ozone is, how ozone is important for us. It helps to protect us from the UV rays, that is ultraviolet rays which comes from the sun, the harmful ultraviolet rays which reaches to the sun. The ozone layer protects us. Alright, so and these chlorofluorocarbons, if it is present in abundant quantities in the air from AC and from the refrigerator, from this sprays, got it, and from the cleansing agent which is being going to the atmosphere, it helps to deplete the ozone layer. That what it does, that it ozone decomposes to give you O2 plus O. Ozone is what? O3. O3 decomposes to give you O2 and O. Alright, so hence depletion of the ozone layer means ultraviolet rays, the harmful ultraviolet rays will reach to the sun and we can suffer from many diseases like skin cancer and so on. Got it? So hence nowadays we are using, that is, hydrochlorofluorocarbons, which acts as a substitute for these chlorofluorocarbons. Alright, now you may ask that why did I say you this particular one? On the basis of refrigeration. Because ammonia is used as refrigeration, chlorofluorocarbon is also used as refrigeration, but they are having adverse effect on the atmosphere. But nowadays we are using hydrochlorofluorocarbons, HCFC, hydrochlorofluorocarbon, which acts as a substitute for chlorofluorocarbon and which reduces the adverse effect into the atmosphere. Got it? So this is all about your ammonia chapter. Thank you very much.